Insertion sort grows a sorted prefix on the left. Each step takes the next key, shifts larger values one slot to the right, and inserts the key in place. It is in place, stable, and is the usual sort inside bucket sort bins. Use insertion sort for small arrays, nearly sorted data, or as the in-bucket sort in bucket sort. It needs only constant extra space, is stable, and does few writes when items are already close to their final spot. Skip it for large N where order N squared shifts her, prefer merge sort or quicksort instead. Outer index I splits the array. Indices 0 through I-1 are the sorted prefix. Index I marks the next insertion slot. Everything after I is still unsorted. Each pass grows the prefix by 1, I moves right until the whole array is sorted. We left off with a sorted prefix on the left and I at 1. Next we run the first real insertion into that prefix. The plan: save the key at I, let J walk left through the green sorted cells, shift every value larger than the key one slot right, then put the key in the gap. The key is 2. Pull it out of the array so later shifts do not overwrite it. Start J at I-1, index 0. J moves left, the small arrows show that scan direction. At J equals 0, 5 is greater than 2, so slide 5 one step right. That is a shift, not a swap. J steps past the left end. Drop the key into the open slot at index 0. The prefix is now 2, then 5. From here the same steps repeat. I moves right, each pass grows the sorted prefix by 1. At I2 the key is 4. 5 is larger, so it shifts once, 4 sits between 2 and 5. At I3 6 is already in place, compare once, no shifts. At I4 the key is 1. Every value in the prefix is larger, so 4 shifts, then 1 goes to index 0. At I5 the key is 3. Shift 6, 5, and 4, insert 3. The array is sorted. Best case, the input is already sorted, or already almost sorted. At every I, compare the key with the cell to its left. If that value is smaller or equal, we stop, no shifts. That is n-1 comparisons and order n time. Reversed input is the worst case at order n squared. N is the length of the array. Worst case time is order n squared, each pass can shift up to I positions, and I runs from 1 to n-1. Best case is order n when the input is already sorted, 1 compare per pass, no shifts. Space is constant, insertion sort works in place with only the key held aside. Define insertion sort on the array. Store the length as n. Outer loop, index I runs from 1 to n-1. Save the key at position I. Start J at I-1 for the leftward scan. While J is valid and the left cell is larger than the key, keep shifting. Slide that larger value one slot to the right. Move J one step left. Place the key in the open slot after the scan. Return the sorted array.